All right, so now we can start discussing some basic properties of waves. Waves is anything that travels like this, even if it's just one wave or multiple waves. So let's discuss the basic parts of the wave. A wave, first you have the equilibrium point. That would be if you were in the ocean and the water was completely level and it was sitting there, that's your at-rest equilibrium point. When it's at its maximum amplitude, amplitude being height of the wave, that's known as the crest, and where it dips down, that's known as your trough. Keep in mind the amplitude for normal oscillating waves, or harmonic waves, the amplitude up is equal to the amplitude down. So you can measure the amplitude down, or you can measure the amplitude of a large wave, assuming they're being sent out with the same amplitude. So let's assume we have a 2-meter wave traveling to the right, coming into contact with a 3-meter wave traveling to the left. How would they interact with each other? Well, think about being in the ocean. If you have a 2-meter wave coming this way and a 3-meter wave coming this way, they will, when they overlap, they'll make a huge giant wave. And that's called constructive interference because they're working together, they're constructing, they're building. So now you have a 5-meter tall wave. And after they pass through each other, it's just like it would seem. The wave continues passing along. So this wave would continue traveling this way, and this wave would continue traveling to the right. So after the waves have overlapped, made a giant mega wave, now you have a 3-meter wave moving to the right, and a 2-meter wave moving to the left. Now what happens when the waves are working against each other, or when you have a crest moving towards a trough? So we have a 2-meter crest moving to the right, and we have a 3-meter trough moving to the left. When they overlap, what's going to happen? Just like the opposite of this, instead of building together, they're going to work against each other. Since they're not the same magnitude in their amplitudes, the 3-meter wave is slightly more significant than the 2-meter wave. So that 3-meter wave is going to win by 1 meter. So you're going to have a wave that has 1 meter in amplitude, but it's more down than up. And then just as before, they're going to continue passing right through each other. Or rather, the 3-meter wave is going to continue traveling this way, and the 2-meter wave is going to continue traveling to the right. So that's one wave and how one wave can interact with another wave. But oftentimes in physics we discuss harmonic motion, or the repeated sending of waves, the repeated waves coming from some source, whether it be sound or light or even an ocean surface wave. Let's say that a string is oscillating up and down. And it's going up and down and up and down and up and down and up and down. In fact, I'm going to change it to the ocean so you can be standing in the ocean. And these waves just keep coming in, up and down and up and down. And I'm going to make 1 meter amplitude. So 1 meter for the crest, 1 meter for the trough, 1 meter for the crest, 1 meter for the trough, and so on. We need to discuss several important properties. You're standing there, unfortunately you have your watch on you. We need to discuss what a full wave is. And to discuss a full wave, we need to know what a period is. Period is the amount of time for one full cycle to happen. One full cycle of the moon would be the period of the moon. One full cycle of an engine going all the way around is your engine cycle. There are periods for anything that goes back and forth. With a grandfather clock, the pendulum swinging back and to its original point is the full period of a clock. And the same is true for any wave traveling. The wave would have to go up and back down. So right there we have one full wave. You could also say, okay, well it's the amount of time from one crest to another crest, or one trough to another trough. All three of those is the exact same amount of length. It's the exact same wave has gone by you. You have between those two half crests, a full crest, and you have a full trough, or a full crest and a full trough. Either way, you have one full wave consisting of full crest and full trough. And the period is the amount of time from one wave to the beginning of the next wave, or the crest of one wave to the crest of the next wave, or the trough to the trough. You get the idea. So the period is the amount of time for one wave to occur. But let's say you didn't want to measure it that way because there are so many waves going on. Let's say multiple waves keep crashing into you. In that case, you would probably measure the frequency of the wave, or number of waves per second. So you're standing here, wave, 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 and let's say 5 waves hit you every second. The frequency would be 5 oscillations, 5 waves per second. Or rather, when you have 5 oscillations per second, it's called 5 hertz. And it's important to note that frequency and period are just the inverses of each other. So period is 1 over the frequency, or frequency is 1 over the period. Now we need to discuss the speed of waves. Speed is frequency times the wavelength, and you can rearrange that equation in any way you like, as long as you don't change the normal direction of it. So when we talk about the speed of the wave, you pick any point on the wave and you measure how quickly it's propagating, or how quickly that part of the wave is moving forward through space. So let's say we have a wave that's traveling through the ocean at 10 meters per second, and you measure the wavelength of that wave to be 2 meters wide. To find the frequency, all you do is plug it into your equation. Frequency is velocity over wavelength equals 10 meters per second divided by 2 meters. So your frequency in this case is also